Hello guys, welcome to Physics Desk. So before going ahead with the part 6 of this video, please make sure that you watch all other videos of electric charges and field. So in this video, I am particularly focusing on electric dipole. So when we are talking about electric dipole, there comes some certain topics under electric dipole such as physical significance of electric dipole, dipole moment, dipole field, force and torque acting on electric dipole, and potential energy of the electric dipole and field due to electric dipole. So these are the sum of topic which I am going to cover in this video. So stay tuned. So first topic is electric dipole. So what do you mean by electric dipole? So if we have two charges which is in opposite, that is if we consider minus q, then the another charge must be plus q. So if we call a system as dipole, then a system of two equal and opposite point charges. So we already know what is point charge is. So it is a very small charge, then only it can called point charge. So a system of two equal and opposite point charge separated by a small distance is called dipole. So we need two charges which is equal and opposite point charges. That is, if we consider minus q here, then another one must be plus q. That is separated by a small distance is called dipole. So then we need to know some of the physical significance of electric dipole. So the first one is the line joining the two charges is called dipole axis. So dipole axis is nothing but the line joining the two charges. So in this diagram, this line is known as dipole axis. And second one, the length of the dipole, is always 2a. So this is the constant value. If we set to be 2 point charges are in dipole, then the distance between those 2 point charges is always 2a. So this value is very important when it comes to the numericals of this chapter. So if a question is given to calculate some force or field of the dipole, then the distance between 2 point charges is not given, then we always must consider the distance between 2 point charges as 2a. So that is the constant value. So always the dipole distance, that is the distance between 2 point charges, is always 2a. Third one, the length of the dipole is a vector whose direction is always from minus q to plus q. So the dipole direction is always from minus q to plus q. So if we consider plus q here, minus q here, which is separated at a distance 2a, then the direction, the length of the dipole, the direction is from minus q to plus q. So always the length of the dipole is a vector whose direction is from minus q to plus q. Fourth one, the total charge on the dipole. So how to calculate the total charge? That is minus q plus q. What is the value? Minus q and plus q cancel out each other, so this value is 0. Hence, we can say that the value of total charge in a dipole is always 0. But what about the electric field? Electric field, since q is 0, but the electric field due to the electric dipole is not equal to 0. This has some value. It is because the charge minus q and plus q are separated by some distance, that is 2a. So since the charges are separated by some distance, there will be a relevant field due to these charges. That is, electric field is not equal to 0 because the distance between two charges has some value. Hence electric field due to electric dipole is not 0. So this is all about the physical significance of electric dipole. Then if we move on to the next topic, that is electric moment and dipole field. So dipole moment is measure of the strength of the electric dipole. So dipole moment is the measure of strength of the electric dipole. The dipole momentum of an electric dipole is a vector whose magnitude is equal to the product of either charge and the length of the dipole. So suppose if we consider dipole moment as P, then it is represented in mathematical form as it is the product of charge. Charge is represented by Q and the length of the dipole. So what is the value of length of the dipole? That is 2a. So the dipole momentum is Q into 2a. So this is the equation to calculate the dipole momentum. Then the direction of the P, that is dipole momentum, is along the dipole axis. That is, if we consider minus Q and plus Q, then the dipole momentum direction is along the dipole axis from minus Q to plus Q, and the SI unit is coulomb, that is charge, and 2a is the distance, that is meter. So this is the SI unit of dipole moment. Then next, moving on dipole field, that is the electric field produced by an electric dipole is called dipole field. That is the electric field produced by an electric dipole is called dipole field. Then the total charge of the electric dipole is 0. So just now we calculated total charge on electric dipole is always 0. This does not mean that the field of the electric dipole is 0. Since the charge Q plus Q and minus Q are separated by some distance, the electric field due to them which added do not exactly cancelled out. So electric field does not equal to 0. Dipole field is also not equal to 0. So this is all about dipole moment and the dipole field. So we know that force and torque are relative term, and the force comes into picture when we have linear motion, and torque comes into picture when we have circular motion. So force is the net force on an electric dipole is an uniform external field is 0. So always the net force which is acting on an electric dipole in an uniform external field is always 0. And torque, when we talk about torque, an object with an electric dipole momentum is subjected to a torque when it is placed in an external electric field. So the torque tends to align the dipole with the field. For a specially uniform electric field E, the torque is given by P, that is dipole momentum into electric field. So where we know that P is nothing but the dipole momentum, and the equation is 2Q into 2A. The magnitude of torque, that is tau, depends on the angle between P and E. So if the angle between P and E, suppose it is perpendicular, then we need to substitute theta as 90 degree. If it is less than 90 degree, then the value of torque will changes. So depending upon the angle between P and E, the magnitude of torque will change. Next, the potential energy. When we talk about potential energy, that is, it is represented by U of an electric dipole in an electric field, also depends on the relative orientation of P and E. So the potential energy is also depends upon the angle between P and E, how it is oriented, and that value are mainly the potential energy value is always depends upon the angle between P and E. So we can write this expression for potential energy of a dipole in an electric field as the dot product of vector P and E. That is, U is equal to P dot E. So this is the equation to calculate the potential energy. So when we talk about the field of an electric dipole, the electric field of a pair of two charges. So when we talk about dipole, there will be two charges, that is equal and opposite charges, plus q and minus q, at any point in space can be found out from Coulomb's law and superposition principle. So we already know what is Coulomb's law and what is superposition principle. So the results are simple for following two cases, that is the field of an electric field when we have two charges plus q and minus q can be found by using Coulomb's law and superposition principle. So first condition, when the point is on dipole axis, and second one, when plane of the dipole. So we need to calculate the equation for electric field when the point charges are placed in the dipole of an axis and when it is placed in the equatorial plane of the dipole, that is perpendicular to the dipole axis. So there are two derivation for the equation to calculate electric field that we will study in our next video. So now we have the clear idea about what is electric dipole, physical significance of electric dipole, force and torque acting on the electric dipole, and potential energy of the electric dipole. So before going ahead with the derivation of electric field intensity on axial line of the dipole as well as equatorial plane of the dipole, we need to know these points, that is electric dipole. So this is all about electric dipole. So this is all about electric dipole, and I will continue to solve or derive the equation to calculate electric field due to 2-point charges along dipole axis and along an equatorial plane in my upcoming videos. So thank you.